Hi guys, welcome. Today I'm going to talk about something interesting. Um, you know, an interesting thing. My son's 2 years old and he likes buying balloons. Um, the helium-filled balloons that float up in the air. And the other day, one of the balloons started sinking. So kind of the idea popped in my mind. Maybe I should use this as an example to demonstrate what density is, what air is, what fluid is. So let's talk about that. Like we talk about a helium filled balloon, and people always think like helium as this magic gas. Like, oh, you put that in the balloon, and the balloon's gonna go up in the air. So without using numbers, just theoretically, what happens is air, air that's in the atmosphere has a certain density, and air is a fluid, and it has a certain density. The symbol for density is rho. Don't worry about why it's rho, just leave that. But what happens is now, this is the air, atmospheric air. And I am standing here in my living room. Now, I buy a balloon and fill it up with helium. Now, the formula for density is mass divided by volume. Now, what happens is when my density of the balloon is lesser than the density of air, the balloon's going to go up in the air, and it will this is probably closest I could draw like a balloon, but yeah, then it's going to be up in the air. Now, air is a fluid. So since the density of the balloon filled with helium is less than that of the air, it's gonna float up in the air. What's interesting is I was giving him a bath the other day, and he took his balloon in the bathtub. So let's say this is the bathtub, and it had water in it. He took his balloon in it. Obviously, the balloon, just on the surface of the balloon, got some particles of water, and the balloon was no longer floating up in the air. You know why? Because the weight of the water just on the surface, just some droplets of water, added to the weight, and when according to this equation, the water that was added increased the mass of the balloon, and that increase in the mass caused the density to go up. Now, what did I say? If the density of a fluid is less than the density of the fluid that it's submerged in, the lighter fluid or the lighter density is going to always be on top, and the heavier density is going to be at the bottom. As soon as this happened, the water got on the surface of the balloon. It wasn't floating up in the air. I took a towel, I wiped it down, I got rid of all these particles, and sure enough, the balloon was back up in the air. A few days later, I think about like a week later, obviously, the balloon started losing some air, and the balloon started losing some air. Now, what happened is the uh, the the balloon shrunk. So this is the inverse reaction. The volume. So the balloon shrunk. When the balloon shrunk, the volume of the entire balloon, it was this big, it became this. The volume went down. Now this is the inverse proportion. When the volume goes down, the density went up, meaning the density of the balloon was not less than that of the air, and it stopped floating up in the air, and it's actually laying in my living room downstairs. So that's an interesting example and an interesting way to explain helium or density. Helium is not it is a magic, it's an inert gas, but it's also not this magic gas that's going to make you float up in the air. it literally follows basic Archimedes principle of um, when two fluids are mixed together, the buoyant fluid is always with the less density. So another great example is, again, let's use water. And there is a ship sailing in the water. Now, what happens is the hull of the ship is like a balloon. It's the volume is so high and the mass is so low that it makes it's the density of that hull of the ship or the entire vessel or the entire container is less than that of the water, the fluid in which it's submerged. So what happens, it always keeps floating up on the water. You know, in fifth, well, not even fifth, maybe third grade science class, they teach you that things that float on the water, things that sink, like a piece of iron is gonna sink. It's true, but it's not true. It's theoretically it's not true. Floating or sinking of an object does not relate or is not dependent on what object it is, but it is dependent purely based on the density as long as it's in the fluid. Because if the density of the floating object is less than the density of the fluid in which it's submerged, the lighter one's always going to be on top. Take a balloon up in the space, up in the vacuum, and try to let it go into space. It's not gonna float. It's gonna just sink. It's gonna go nowhere. It's gonna it's gonna just keep sinking because, or it's not gonna follow the pattern because of this, because space doesn't have fluid, space doesn't have air, it's vacuum, so the balloon's not gonna float. So going back, right, like you can make a ball of cast iron, keep it completely hollow, just the outer shell, make it so thin that it has got the mass is, I'm gonna write it here. So the density equals mass times mass divided by volume. So the mass of this big giant ball of iron is so low and the volume is so high that the density is higher than the fluid that it is in, and it's gonna float. As simple as that. There's nothing to do with what the object is made out of. Is it plastic? Is it iron? Now, naturally, the selection of the material has its natural tendency to make it float or make it sink based on how the molecules are packed. Are they densely packed or are they lightly packed? You could take a piece of wood and make it sink if it's a densely packed wood. But what you learn in your second, third grade is like, oh, wood's always going to float on the water. Not true. Again, follow the principle density equals mass divided by volume. When the volume goes up, density goes up, mass goes down, density goes up, mass goes up, density goes up. As simple as that. If you know this equation, density equals mass times volume, you pretty much would know if an object is going to float or sink in a fluid. When I say fluid, for layman's terms, it's either water, air, something of that sort. Hope you like this and hope you learned something.